All right, so this is a continuation of the factor label method using the Packing Peanuts lab activity handout. We're now going to move on to question number 4. This is an example that I did not have a chance to show you in class, so I'm going to show it to you right now using the factor label method that I just introduced you to in the previous video. All right, so let me just quickly erase all of this so we can start all over. Okay. So question number 4 reads, what is the mass of a dozen of each kind of packing peanut? All right, so I know that all of us know that a dozen basically means 12, and you can very easily solve this problem without showing any work. However, since the purpose is to show you how to use the factor label method for simple problems, I want you to bear with me and just kind of walk with me through this process so you can see how to use this method for harder questions down the line. So the conversion factor we'll be using here is 12 packing peanuts is basically 1 dozen packing peanuts. All right, so to turn this into a conversion factor, I basically set up a ratio or a fraction. So there are 2 ways of writing this. I can write it as 12 packing peanuts over 1 dozen. I could also reverse this so that it reads 1 dozen over 12 packing peanuts. All right, these two are equivalent, and the one that I choose really depends on the situation. It depends on what I am starting with and where I hope to go. So, since the question is asking for the mass of a dozen of each kind of packing peanut, I am starting with the given information, which is 1 dozen. And let's say that I am starting out with the green variety. 1 dozen green packing peanuts, right? And I ultimately want to figure out the mass. So my end goal is to get to mass. So the way to set this up, again, I set up my grid. I have 1 dozen on the top. In order to get to mass, I need a second conversion factor because I don't have mass anywhere in this situation here. There's no mass there, there's no mass there. So I'm going to start by setting up a second conversion factor. So my second conversion factor is going to be the same one that I used earlier on. And that one is basically that 5 packing peanuts, and here's the green variety, has a mass of 0.76 grams. So I can express that in 2 ways, 5 packing peanuts over 0.76 grams, or I can reverse it and have 0.76 grams on the top and 5 packing peanuts on the bottom. All right, so let me go back to the problem over here. So I'm going to start by setting up my first conversion factor right there. Since I want to eventually get to mass, I want to somehow cancel out the dozen. So I'm going to write down on the bottom here, 1 dozen is the same thing as 12 packing peanuts. So you can see how I basically chose, this conversion factor right there, which takes me closer to my end goal, which is mass. All right, so that's the first part of my grid. I'm going to continue on, because I'm not done yet, and set up my second conversion factor. And with my second conversion factor, I basically want to cancel out the particles, packing peanuts. So I want packing peanuts on the bottom right there, and so that means I am going to choose this conversion factor. So here I go, 5 packing peanuts on the bottom, 0.76 grams on the top, and I can tell that I'm setting up this problem correctly because the packing peanuts cancel out diagonally, all right? And the reason for this is because the way the grid is set up is everything on top is multiplied, everything on the bottom is divided. So if I have packing peanuts on top and I have packing peanuts on the bottom, they basically cancel out. Since I have dozen on top and dozen on the bottom, they also cancel out. So I am conveniently left with grams, which is a measure of mass. So I know that I have set up everything correctly. So at this point, I'm going to type this up into my calculator. All right, so advertisement, let me get rid of that. All right, go away, go away. All right, there we go. So I'm going to take a peek over here. So I'm going to multiply 1 by 12 by 0.76 and divide everything by 5. So 1 times 12, again, just to show you, is 12, no surprise there, times 0.76. Divide by everything on the bottom, which is 5, divided by 5, and that gives me an answer of about 1.8 grams. All right, so final answer there is about 1.8 grams. So this is how much 12 packing peanuts or a dozen packing peanuts will weigh if I'm dealing with the green variety. All right. Okay, I'm going to show you the full process now for the second kind of packing peanut, the red variety, and this time I'm just going to quickly show you how to do it because you've already seen the full explanation earlier on. So I start with my given information. I have 1 dozen of the red variety. I know that in 1 dozen, I basically am dealing with 12 packing peanuts. I know that of my red variety, 5 packing peanuts has a mass of 0.30 grams. So, to make sure everything's set up correctly, I notice that dozen cancel out diagonally. Packing peanuts also cancel out diagonally. I am left with grams, which is a unit for mass, which is what I want. So you can see here how I employed one conversion factor right there that links dozen to packing peanuts, and a second conversion factor right there that links packing peanuts to grams or mass. So at this point, I am ready to type this into my calculator. So I have, all right, advertisement again, sorry about that. I basically downloaded a free calculator, so I have to deal with the ads. All right, so I have 1 times 12 times 0.3 divided by 1, which is going to be the same thing, so I'm just going to divide it by 5 on the bottom, and that gives me 0.72. So 0.72 grams.